Okay, so for using this multimeter, what I've been doing, I got this process kind of just through a mix of AI and reading stuff and experimenting. Start by going to the, I don't know if you could see that. So when I turn it on, I guess this isn't going to be an SOP probably, but if it is, it would be good to go from the beginning. So it starts on measuring amperage. So I'll just change it to the ohms or to the resistance, and then to get something that has been really good that I didn't know is to hold them flat against each other and to make sure to have constant pressure just when doing everything. And then I press REL relative. It's kind of like zeroing it out to get rid of the lead resistance. My finger slipped when I was measuring it, so I'm gonna, there we go, re-zero it. We'll start with, so there's two aluminum ones. There's one that does not have a adapter on it, and that's this one. And then there's this other one. I'm not sure why it comes with that. It just makes it harder to connect everything. But start with the wand, self to self. And you get a good, this is a lot harder to do, trying to get both the reading and the process. So yeah, when I hold still, as you can see, it stayed steady around 10 to 20. I don't know why it's fluctuating so much now, but that's another thing I want to look into is why it fluctuates so much. I think it might be because of like small movements that I make, like when I'm talking or breathing. It seems to be a little more variant than when I'm just holding as still as possible. So maybe I can get it to be better here. Yeah, so when I'm holding still and not breathing or moving, it's around 0.5 to 0.6. So that one's good. And then with the adapter, and between the adapter and the wand, around 10. How's it going, Audrey? And then I'll do self to self on the adapter. That looks good. And from adapter to the hose. And about 50 mega ohms or milliohms. And then I'm going to be going from this end of the hose to back to this end. Yeah, so that resistance is a lot bigger. I need to look more into why that might be. So right now that's saying that's negative 100 milliohms. Interesting. And yeah, when I did this on Thursday, the self to self between the ends of the hose was by far the greatest resistance. I really hope that works, or that we can find a way to fix it, because I don't know what other hose we would buy, because this one's brand new. So now doing between the hardest part for this is, let me try and adjust, is holding it still, because even small movements can make it really hard to measure, and there's not, like on some of these, not a great place to, if I did use alligator clamps to clamp it in. I guess maybe I could just take this off and clamp it onto here for these. Okay, I might try this again with alligator clamps. So I have that. I'm looking at here. Let me adjust the camera and adjust my hole on the probes. My finger slipped. Before it slipped, it looked like it was about 0.6. Let me try that again. Okay, yeah, so 10 milliohms. That was between the hose and the inlet pipe, or inlet valve, inlet area, not sure what that's called. And between I'm gonna take this off now. Or I guess I'll leave it on. I don't know if that'll affect it, but leave it on just in case. And then self to self for the inlet valve. Negative. I'm not sure how that works. I'm gonna try moving positions, see if that helps at all. So now I have one on top and one on bottom. My fingers are slipping again. It seemed to be around in between 0.1 and between 10 and 70 milliohms. I'm not sure why it's negative. I wonder if, because negative relative to the lead resistance, which has now decreased. Yeah, so I'm not 100% sure how accurate this is. I might try talking to the Ekin people and see what they suggest. So then I'm doing between the main body and the inlet. This one's fluctuating a lot. Maybe I don't have the steadiest hold. Let's see. Set it down here. Should be a little more manageable. We're at negative 0.05. Let me try. I'm gonna tear it again, zero it out. Okay, let's try this one more time. I'm gonna go, now that I've re-zeroed it, I'm gonna go part to part for the inlet. Okay, that seems to be my right. 40 milliohms, so now from the inlet to the main body. it's fluctuating a lot. When I only have the tip pressed against the metal, it's a lot less accurate. I don't know why this one's so variant. Okay, so okay, there we go. So that is again between the inlet and the body. That was around 40, it's around between 40 and 60 milliohms. So now we'll do self to self on the body. Depending on how my pressure is against the probe, it changes it a lot. The more pressure I put in so when I have the flat or the long side press as much as I can against it, then it fluctuates a lot less and it is lower and it seems to be more accurate. Now why is it moving around so much? Maybe because my finger's slipping down. So if I go press against that little lip. Oh, now it's moving around. Okay. Let me try that. Oh, there we go. It's a lot better. So yeah, holding it against something that's a flat space if possible seems to be a lot more accurate. Now I'll go between the body and the top lid. That. So we have 0.01, 20 milliohms. This looks to be a lot more accurate as well. Or I think my method is better from when I was measuring it on Thursday, because I also was not pressing as flat as I am now, or applying as much pressure as I am now, and I'm not keeping the probes as flat against the vacuum. I wasn't keeping it as flat then as I am now. So I think these are going to be more accurate. So now I'll do self to self on the lid. It's about 30 to 40 milliohms. So everything so far except for the hose, if I remember it, has been within an acceptable range. So now it says measure between the grounding portion here and the lid. So that's what I'm going to be doing. I'm going to reorient the camera so that can be seen. This is way harder than it should be. I'm just going to move the whole vacuum over. Okay. That's what I'm going to do in the first place, but I did not think of that. So now I have both of them flat. Okay, that looks good as well. Around 20 to 30 milliohms. And here's the grounding. This one is going to be interesting because it's so variable and there's not really one specific flat place I can go. Yeah. It's fluctuating a ton. In the PDF, it talked about testing it against this. It didn't say anything about testing this mesh that's on the power cord. So I'm not sure how much to rely on that, and also it doesn't have any flat solid area where I can press it, where I've seemed to be getting a lot more reliable readings. Yeah, so I'll look more into that. But I guess I need to do self to self on here as well. This circular ones are hard to get. My fingers slip a lot. Let's see if I kind of have it clamped down on either side by my fingers. Still fluctuating a lot. And I don't even know where I'd put the alligator clamps on this. Let's see if this works a little better. Keep it in those little cracks. Now we're at negative 10 milliohms. So maybe not. Okay, there we go. So I'm just holding it flat against. That's probably as flat as I'm gonna get it. And there's a lot less slipping. Oh, my finger's already slipping again. Now we're at negative. Okay. So, yeah, I'm not sure how or where the most accurate reading is for some of those that move around a lot, but I feel like the best is when it's not slipping and when it's not fluctuating, and it's when I'm putting as much pressure as possible against these and having as much surface area contact between the probes and whatever part of the machine that I'm testing. I can do the bottom lid now. This one's going to be super fun too, to find a flat spot to get an accurate reading on. Yes, I'm going to press it up against this upper lip. Oh, there's a gasket in the way. Let's see. I wonder. So this is one of the hooks. Not one of the hooks, but one of the one of the pieces that helps it stay connected to, helps the bottom part stay connected to this whole machine. I'm gonna use that and see how solid that is. Okay, I'm looking at it right now on the multimeter and it's fluctuating a lot. I'll have to if I just hold it there, instead of moving around too much. Maybe if I hold it flat against this edge, that seems like it's a little more solid. No, that's fluctuating a ton. I might have to come back to that one and see what it's like, but for the most part, it seems like the body is fine, and the attachments as well. I guess I do need to test this other hose. Maybe while I'm filming this, I can figure out what the best way is to attach this one. And if that's attached, well, I think I tried it and I'm not sure. Oh, that one fits in there as well. It's just not tightening. That was it. It doesn't seem to tighten super well onto this. There we go. I just need to go all the way. It's still a little bit loose, but I think it should be fine. So now we can also test between the two hoses, or the two wands, I mean. Around 30 milliohms, and this is how I'm holding it. So now to test within this wand, try to lay it flat. Okay, now from here to the coupler, I'm gonna take off this other one that's getting in the way. So there's that. Let me see, why is it still fluctuating so much? Don't like how much it's moving around. And try what is going on? So I'm not sure how much I trust that reading. Trying to think of what I can do, because I feel like I'm laying it fairly flat. Applying equal pressure. Okay, maybe that one just isn't up to date either, so that, or up to standard, so that was between the coupler and the aluminum wand with a coupler as well. Or stainless steel, I don't remember what this is, I think it's aluminum. But yeah, that should be testing all the parts with each other and also between themselves.